What's going on, guys? In this video tutorial, I will be showing you how to factor polynomials using a special factoring pattern called the difference of two squares. So let's look at what the difference of two squares factoring pattern looks like. So the difference of two squares factoring pattern is a bit of a variation of the special product pattern, the sum and difference. All it is just it's switched around. So you have the a squared minus b squared in the front, and it's going to be equal to a plus b times a minus b. And I'm going to show you step by step with the difference of two squares factoring pattern. So I just kind of wanted to show you where it originates from or where it comes from. All right, so let's dive into the problem that we're going to be looking at, where we're going to be using this special factoring pattern. Now, I do want to throw in a bit of a disclaimer. This special factoring pattern is not always going to be a pattern that you're going to be able to use. You're going to have to analyze the polynomial that you're dealing with and determine whether this specific factoring pattern falls in line with the setup of your polynomial. So in this polynomial, this is another example that's a little ambiguous. It's not straightforward. We can't really see if it falls in line with this the difference of two squares factoring pattern. We're gonna have to do some rewriting. So I'll show you guys how I went through that process. So what I'm gonna do is I wanna try to get 4m to the fourth minus 25. I wanna try to match it up as best as I can to the difference of two squares factoring pattern. So if you look on the bottom here, I wrote it up earlier. So the factoring pattern, as I mentioned earlier, is just swapped from the product pattern. It's a squared minus b squared is equal to a plus b times a minus b. So this part right here, this is the factored part. So we want to try to get this polynomial because you can kind of see that you can write it in a squared minus b squared form. And I'll show you what I mean. So I know that 4m to the fourth power minus 25, I can rewrite this as I can rewrite this as 2 to the second. So I took that 4 and I wrote it as 2 to the second because it's 2 times 2. Next, I'm going to take this m to the fourth power, and I'm not going to do anything to it just yet. I want to show you step by step. I'm also going to take this 25 and I'm going to write it as 5 squared, or 5 to the second power. Because 5 to the second power, we know that it's the same thing as 25. So we're slowly starting to see that this polynomial is beginning to take form of the difference of squares factoring pattern. So the next thing that I'm going to do is, if you guys remember, one of the exponent, when you're multiplying exponents, there's a rule called power to power, meaning that you can factor out a power as long as you put it in outside of a parentheses. So what I'm going to do is I'm going to take this 2 and watch what I'm going to do. I'm going to rewrite this as 2 to the first power times m to the second power. This is going to be, and I'm going to write a parentheses, and I'm going to put the power of 2 on the outside. So the reason that I did this is because according to the power to power rule, whenever you have a power outside in parentheses and then you have powers inside, you're going to multiply those powers from the inside to the outside. So if you look and you compare 2 to the first power, or just 2, and I take this power outside and I multiply it with the power inside, it's going to give me the original power of 2. If I then go to my m to the power of 2, using the power to power rule, I can go back to the original m to the 4th power, because I have m to the 2nd times the power of 2. 2 times 2 will give me 4. All right, the next thing I'm going to do, I'm just going to bring down the 5 to the 2nd power. And now if I look at my polynomial in that I rewrote, and I then compare it to my difference of two squares factoring pattern, now we can see a little bit better what our known value of A and our known value of B are going to be. So I can see that my A is going to be this chunk right here. That's going to be my A. So my A, and by the way, guys, I just put 2 to the 1st power just for the purpose of instruction so that you can kind of see that power to power rule. But I'm gonna remove it now. It's gonna go away so that you can kind of see, just so it doesn't throw you off. So I'm gonna write A is equal to 2m to the 2nd power. That's gonna be my A, and my B value is going to be just 5. So that one's not that bad. So I have my A, I now have my B value. I'm gonna take these values and I'm going to then write my polynomial in factored form. And by the way, I forgot to underline my B value here. Okay, so again, using the factored form, I'm saying that, let me, matter of fact, get a little bit closer here. I'm gonna move this closer. So my polynomial was, I know that my polynomial was 2m to the 2nd power to the 2nd power minus b, or my value of 5 to the 2nd power. And if I use the difference of two squares factoring pattern, my factored form is going to be a plus b, and I know that my a is 2m squared. I know that my b is 5. And I'm then going to write the next part, which is a minus b. Again, my a is 2m squared, and my b is going to be 5. So there you have it, guys. We went from 4m to the 4th power minus 25, and we were able to rewrite it in such a way that we could use the difference of two squares factoring pattern. And we learned that when we use this factoring pattern, our factored form of our original polynomial is going to be 2m to the 2nd power plus 5 times 2m to the 2nd power minus 5. And I'm going to go ahead and rewrite this in solid black, because this is our factored form of the original polynomial. So there you have it, guys. We were able to take 4m to the 4th power minus 25 and rewrite it so that we could use the special factoring pattern difference of squares, which then gave us a factored form of 2m to the 2nd power plus 5 times 2m to the 2nd power minus 5. And we get to this point and we can't factor it any further, so this is going to be our final answer, or our most factored form of 4m to the 4th power minus 25. So hopefully you guys found this video tutorial helpful. These special factoring patterns, as I said earlier, you're not always going to be able to use them. You have to analyze your polynomial, take a closer look and see if there's a way that you can rewrite it so that this factoring pattern can be used. Otherwise, you can go about factoring your polynomial using some of the other methods, such as finding your greatest common factor, factoring using the X method, factoring by grouping, and so on and so forth. So I hope you found this video tutorial helpful. Stay tuned for other math video tutorials, and I'll talk to you guys soon.